Good morning, you guys. Today we're going to take a look at quadratic functions. We're just going to start with the basics. So we're going to get some vocabulary down today, refresh your memory from Math 1 and Math 2 about quadratic functions. Then I'll show you how to verify if two binomials, if we multiply it out, if it's going to be a quadratic function. And then I'll show you how to use Desmos to do max and min. So some of this hopefully you remember, but it may have been a while since you've done math, which is not an issue. So we'll get you all caught up today. So we're going to be taking a look at quadratic functions. So let's start with some vocabulary. So a function passes the vertical line test. No two x values repeat itself. So that means when you graph it, if you were to draw straight lines through your graph, it should only touch in one spot. So a function passes the vertical line test, and you might have heard of it called the pencil line test. A quadratic function is in the following form. So it's going to look like f of x equals ax squared plus bx plus c. A can be any number except 0. B can be any number, and C can be any number. So B and C can be any number, decimal fractions, big numbers, little numbers. It can be any number we want to, but this first coefficient of A cannot be 0. Now, A cannot be 0 because if I were to put 0 in this place here and multiply it out, it would cancel out that whole term and it would no longer be quadratic. It would only be linear. But we want to make sure we focus on quadratic functions this unit. So A cannot be 0. The shape of a quadratic function is called a parabola. So it makes a U shape that we'll take a look at in just a minute. That's called a parabola. The lowest and highest point is called the vertex. And specifically, if it's the lowest point, it's the minimum. And if it's the highest point, it's the maximum. So hopefully that makes sense. Lowest point is the minimum. Highest point is the maximum. And together, they are the vertex. So for a parabola, all parabolas have a vertex. One vertex is the minimum, and one vertex is the maximum. The line that splits the parabola in half is the axis of symmetry. And the highest exponent for any quadratic function is 2. So the highest power that we're going to be taking a look at, if it's quadratic, is going to be 2. So let's take a look at Desmos and see what it looks like. So I've already graphed our parent quadratic function. That's this function as we see over here. So it's this green parabola here. I just said what the name of it is. So it's a parabola. My vertex is down here. It's specifically at this point 0, 0. So that's my vertex. My vertex for this particular parabola is a minimum. So the lowest point that this parabola is going to get to is the point 0, 0. It will not reach any lower than that. My lowest point is going to be 0. The line that cuts it in half is the axis of symmetry. So that's this pink line that I'm drawing in here. So that's my axis of symmetry. And since this point here was 0, 0, you take the x coordinate. So my axis of symmetry equation would be x equals 0. So this ordered pair was 0, 0. Take the x of your vertex. So I use the first number. Okay. So your vertex is a minimum for this particular example, and my axis of symmetry is x equals 0. That's the vertical equation that cuts this parabola in half. I know it's a quadratic function because if I look over here, my highest exponent is 2. So it's not x to the third, x to the fifth, x to the seventh power. It's x to the second power. So that's another reason I know that it's a quadratic function. So it's a parabola. I got my axis of symmetry. It's the pink line. I know that it's a minimum. And this is a parabola because it's a U shape. So if I take a look at this second one here, so it's going to flip upside down. So the purple one that I just drew in here, this vertex is going to be a maximum for the purple. So the green vertex is a minimum. The purple vertex is a maximum. So if I'm only focusing on the purple, let me get rid of the green. So if I only focus on this purple one here, my vertex is still 0, 0, but this time it's a maximum because that's the highest point that I'm getting to. My axis of symmetry is still going to be x equals 0 because it's going to go through the x coordinate of my vertex. And it's still clearly a parabola. Now I can switch it up and put another one in here. Say we want to do x squared And let's make it do plus 3. And let me get rid of this, okay? So if you notice, I shift the parent function up 3 units, but I still can label all the parts. I know that this point here is going to be my vertex. It's a minimum. My axis of symmetry is still going to be x equals 0 because that's the x coordinate of my vertex. Now, if I made it do something else, let's see what else we can make it do here. Let's do x minus 1. Okay, let's say I want to do this. Notice my vertex change is going to be this point here. So my vertex is the lowest point. It's still a minimum. It's still a parabola because my highest exponent is 2. This time my axis of symmetry would be x equals 1. So this point here, I label that point. That point was 1, 3. Your axis of symmetry goes through the x coordinate of your vertex. So my axis of symmetry would be x equals 1. And my vertex is the lowest point or highest point, but in this case, it's the lowest point, which would be 1, 3. So that's just a little bit about parabola. So far, you should be able to look at a graph and determine what the axis of symmetry is, what the vertex is, and make sure that is a parabola. So if I go back here to our notes here, let's verify if two functions are indeed, if two binomials are indeed a quadratic function. So verifying a function is quadratic. So say I have this example here, 2x minus 1 times 3x plus 5. I want to verify that when I graph this function, it's going to be a quadratic. So there's 2 different ways I can go about doing that. I could do the box method, which is over here on the left-hand side, or I could do the distributive property, which is over here on the right-hand side. Both of these are going to give us the exact same answer. So they're both going to give us the exact same thing. So the first way that I'm going to go through and do it is the box method. So for the box method, I took 2x minus 1 and I put that on top. I took 3x plus 5 and I put that on the side. And we're going to go through and multiply. 3x times 2x is going to give me 6x squared because you add your exponents. 3x times negative 1 is going to give me negative 3x. 5 times 2x is going to give me 10x. And 5 times negative 1 is going to give me negative 5. So this first way is called the box method. So I set up a 2 by 2 box. I put my first binomial on top, the second one on the side, and I went through and multiplied. You combine like terms, and when you combine like terms, 10 minus 3 gives me 7x. So this down here is our final answer. And you can read off your coefficients, A, B, C. A is positive 6, B is positive 7, and C is negative 5. Make sure if it's a negative or something in the front that you include that in your answer. So the first way was the box method. The second way over here is the distributive property. So I broke up my first binomial. I did 2x times 3x plus 5 and negative 1 times 3x plus 5. If you need to put your arrows up here, there's nothing wrong with putting your arrows up there. And notice, once I combine my like terms, I get the exact same answer. A is positive 6, B is 7, C is negative 5. I just read off my coefficients. So we have verified that this is a quadratic function because my highest exponent is 2. And if I were to go graph this, it would indeed be a parabola. The last thing I want to show you is finding your maximum or minimum using Desmos. And we actually kind of already talked about it previously with the parent function. Make sure before you graph it that you move everything on one side of the equation so that it is equal to 0. So make sure before you graph it, this is what I was trying to highlight here. So make sure before you graph it that it's set equal to 0 and everything is over to one side of the equation. For example, I have this x squared minus x equals 6. I cannot type this in Desmos. So x squared minus x equals 6. I need to move everything over to one side of the equal sign. So this is a positive 6. I need to subtract 6 from both sides. And I need to subtract 6 from this side. Now, none of these are like terms. I got an x squared. I got a negative x, and I got a number. None of these are like terms. Since none of these are like terms, I just keep everything separated. Apples, oranges, and bananas, so to speak. I can't put those all together. I keep them separate because they're not like terms. So I have x squared minus x minus 6, and this is what we're going to graph in just a minute. So if everything is not to one side of your equal sign, you cannot graph it. You got to move everything over to one side so that it's equal to 0. So x squared minus x minus 6, that is where we're going to go graph in Desmos. So x squared minus x minus 6. So let me get rid of all of this, and we'll graph it x squared minus x minus 6. So this is what my graph looks like. And I can find the maximum or the minimum just like we did previously. So this is what my function looks like. Desmos generally does a good job of just giving you the actual point. So it's down here at the bottom, 0.5 and negative 6.25. If it wasn't there, you could just scroll over and see what it is. So I know that this is a minimum because this is the lowest point, and your vertex is 0.5, negative 6.25. So a half and then negative 6 1/4. This would be your minimum. This is your vertex. We're saying the same thing. And your axis of symmetry is the x coordinate. So that would be x equals, and I believe that point was a half. So the equation for the line of our axis of symmetry would be x equals 0.5. So there it is there. So it goes with the x coordinate of your vertex. So my axis of symmetry, x equals 0.5. And there it is right there. Let's try one more to make sure you're good to go with today's assignment. Suppose I wanted one that was going a different direction. Let's do negative x squared plus 4. Okay, let me get rid of this one. And let me erase that. Okay, so now we're looking at the one that's in the red. My vertex this time is a maximum. I can find that point. There it is right there, 0.4. It won't always be a whole number, so there's nothing wrong with decimals and stuff that you get. This time, this is my vertex, and your axis of symmetry would be x equals 0. So now you know how to find your maximum and minimum in Desmos. You know how to label your A, B, and C and determine if it's a quadratic function. And you also have your quadratic vocabulary that we're going to keep building on as the days go on.